All right, welcome back. By this point, you have practiced the sum, difference, identities for sine, cosine, tangent. So let's work on some of these problems. So to verify sine of 2x, to say that it's equal to 2 sine of x cosine of x, I would recommend first looking at sine of 2x as sine of x plus sine, or plus x. So sine of 2x as sine of x plus x. And then using the sum identity, you'll be able to write that, and with some simplification, we can work towards getting 2 sine of x. So looking at cosine of 2x, similar approach. We're going to say cosine of 2x is cosine of x plus x. Using the cosine identity for addition, we would write that. Now, the sine of x plus x, the simplification here will be rather simple and straightforward. But when we look at the cosine of x plus cosine of x, to try to get 2 cosine squared of x minus 1, this is going to require a little more simplification, computation, and maybe even the use of an identity. But it is still possible to get. It's just going to take a little more work to get there. All right. So looking at the next problem. So when a wave travels through a string, like a guitar string, the displacement of a point on the string can be shown using by adding these two functions. So we're given these two functions and we're told to add them. So thinking of adding these two functions, let's first just write that. Cosine of 2 pi thirds t plus or minus 2/5 pi x, adding that with a times cosine of 2/3 pi t plus 2/5 pi x. And I would first look at this and see that there's a common a that we can pull out. 2/3 t minus 2/5 x, and then plus cosine of 2/3 t plus 2/5 pi x. And then from here, we can use the cosine rule for this piece, the cosine rule for this piece. You'll notice that some terms will cancel, and we'll be able to combine and simplify. But we will have an a. Our a will still be in our final result because there will not be a way to cancel that. So using the identity for both of them, and you should expect some things to cancel. Moving on. So Mr. Beal feels at times that he carries the weight of the world on his shoulders. So he knows from Mrs. Bright physics class that the force on a person's back when he bends over at an angle can be represented using this. So we want to simplify this expression. So if you're struggling to know where to enter this problem, I would look at this as 0.6w, which I guess would be the weight, or I believe it would be the weight, divided by, that would be work actually, divided by 12 degrees, having that, and then multiplying that by sine of theta plus 90. And then with sine of theta plus 90, we're able to use an identity there, rewriting that, simplifying that. Because of the 90 degrees, I believe some things will cancel in your identity, and we'll be able to simplify it down, where we'll have our initial front fraction being multiplied by a trig function. So identity, simplify, and working down. So best of luck working on these, guys and ladies, and I'll see you in the next video.